Let's talk a little bit about balancing chemical reactions. This is a very fundamental skill to general chemistry, and obviously our objective today is learning how to balance a chemical reaction. I'm going to talk about a few basic things to make sure that this process goes smoothly, and one of those is the difference between reactants and products. So if you're on the left side of the chemical reaction, you are considered a reactant, and if you're on the right side of the chemical reaction, you're considered a product. So reactants go in, products come out. Some key points here to pulling this off is that you are going to be balancing a chemical reaction by adding coefficients so that the reaction obeys the law of conservation of mass. Each side of the equation has to have the same number of atoms of each element. Now you're going to see this carried out with a lot of visual examples, but I just wanted to give you a definition of how this is done. So again, the law of conservation of mass just simply states that mass cannot be created or destroyed. So we're going to make sure that the types and numbers of atoms on the reactant side is equal to the number and types of atoms on the product side. And again, this will make a lot more sense when you start to see some of these examples. Now, since we did use if I go back to this previous slide, since we did use the term coefficient, I just want to make sure that it's understandable what that is. So a coefficient is going to be a number placed out in front of the formula for the chemical. And this is not a subscript. Subscripts are written kind of below each element symbol. So again, you need to make sure that you realize we're adding coefficients, but we are never going to distort or change the subscripts for any of these chemicals that we're trying to balance or any of these atoms. We will start with just a really simple example, and you'll see how easy this is as we process it, but we need to start with something a bit fundamental. So we've got H2 plus O2 produces H2O. Now H2 and O2 are on the left side of the arrow, so they are considered reactants, and H2O is the only product. So something I like to do is draw a T-chart. So I draw the T-chart right in the middle of the reaction. I draw a line straight down underneath the arrow. Now what I'm going to do is take chemical inventory of each atom type and how many there are. The two atom types I have is hydrogen and oxygen, and you'll notice that they're on both sides of the reaction. The next step I'm going to do is count how many hydrogens are on the left side of the arrow and how many hydrogens are on the right side of the arrow. I'm going to do this exact same process with the oxygen. So when I do that, I'm counting the subscripts. So hydrogen, there are 2 on the left and 2 on the right. This is a good thing. It's already balanced, so I'm not real worried about hydrogen at this point. However, oxygen, there are 2 oxygen atoms on the left and only 1 oxygen atom on the right. This is a problem. I have to balance the oxygen. So what I can do is add a coefficient like we saw in the previous slide. I will add a 2, which is in red up here, in front of the H2O. Now when I do this, I have to recheck my inventory and see how this changed the number of each type of atom on the product side. Since I have a 2 coefficient and a 2 subscript on this H2O, then I am going to have to multiply it. So 2 times 2 gives me 4 hydrogens. This 2 coefficient multiplies the entire H2O by 2. So that means that I take 2 times the 1 oxygen, which gives me 2 oxygens. So what I've done here is I fixed the oxygens. They're both at 2. But in this process, I've actually switched the hydrogen from 2 to 4 on the right side. So this is a problem because now hydrogen's unbalanced. So what I'm going to have to do is fix this, and I'm going to do that by adding a 2 to the reactant side. I'm adding a 2 in front of the H2 on the left side. This will cause the number of hydrogens on the reactant side to go from 2 to 4. So now you can see that my chart is complete. You'll always know when you get this answer right or it's complete when the number of each type of atom on the left and right side, the reactant side and product side, is equal. And we can see I've got 4 hydrogens on both sides and 2 oxygens on both sides. So this is a dead giveaway that this problem has been solved. It's finished and I can move on. Now you probably thought, wow, that's a pretty simple process. And that's because we picked a very simple reaction. So what I'm going to look at next is something way more complicated. Okay, so just looking at this reaction in blue, you can kind of immediately see that this is just a more intimidating reaction. For one, I've got way more chemicals involved. So I've got 2 reactants and 2 products this time. And I've got way more atoms involved. So I've got silver, nitrogen, oxygen, and copper all involved in this reaction, 4 different types of atoms. I have to be very careful that I count specifically each type. So you see that I've made my T-chart already, and I've taken the initial inventory count. Now, this can really mess some people up because this problem has parentheses in it, and that's usually an issue. So you can see that this NO3 is surrounded by parentheses, and it has a 2 on the outside. You're going to treat this a lot like you would in math class. That 2 is going to multiply everything in the parentheses by 2. So 3 times 2 will give me 6 oxygens. So that's how I've got the 6 oxygens on the product side. Nitrogen, there's only one of them inside the parentheses, but since it's multiplied by 2, that's how I got the 2 on the product side. That's the only part that's really difficult about this one. I would draw attention to the nitrogen on the reactant side. Just notice that there's only one of those nitrogens because that 3 just specifically goes with the oxygen, and there's no parentheses to multiply this effect out. So there's 1 nitrogen on the left and 3 oxygens on the left. So we've got some issues. Nitrogen's not balanced and oxygen's not balanced. So if we look at this, how to fix this, and I'm going to clear the screen here to get rid of these arrows. So let's do that. So a couple steps here, what I've got to do. I'm going to add a 2 in front of the AgNO3 on the reactant side, and that will change my silvers from 2 on the left, from 1 on the left to 2 on the left. So now I have 2 silvers. And then the 2 also multiplies across to the nitrogen, so now I have 2 nitrogens. And then 2 times the 3 oxygens on the left gives me 6 oxygens on the left. So now I have 2 silvers on the left, 2 nitrogens, and 6 oxygens. On the right side, I've added a 2 in front of the Ag, and that will cause me to have 2 silvers on the right side, which is good because I had 2 silvers on the left side. So that's balanced. And you'll see that this balances out. 2 silvers, 2 nitrogens, 6 oxygens, and 1 copper. Every type of atom is balanced out. Same number of atoms of each type on both sides. Okay. So again, this is a little bit more complicated of an example, but now you get the general idea. The same process will be carried out no matter how difficult the question is. You're still doing the exact same procedures. Now, what I want you guys to do is to try this question on your own. So a good idea would probably be just to pause this video and to try to do this question on your own and see if you can get it right. And then after you have tried it and you've got it finished, go ahead and unpause the video and you'll be able to see if you got it right. So again, if you want to try this and make sure you got it, just pause the video right now. Okay, so let's look and see what the solution to this one would be. So to solve this one correctly, you would need to put a 3 in front of the CO on the reactant side, the left side. And you would need to put a 2 in front of the iron, the Fe, on the product side, and a 3 in front of the carbon dioxide, or the CO2, on the product side. When you do this, and you take chemical inventory, you will see that you end up with 3 carbons on both sides, 6 oxygens on both sides, and 2 irons on both sides. So again, this was just a quick tutorial on how to balance chemical reactions. So hopefully you found this helpful. Again, if you did find this video helpful, please like and subscribe. Thanks, guys.